Dear students, in this small session, we will be discussing sparse matrix, how to transpose it, and an algorithm, an efficient algorithm to transpose. We'll call that algorithm as fast transpose. Why it is fast transpose? We'll come to know once we start checking, once we start applying the algorithm or the steps. To recap, a sparse matrix is a special type of matrix where very less number of non-zero values and huge number of zero values. Such matrices are called sparse matrix. This is ordinary matrix. As we can see, number of zero in that matrix is very less. Sometimes it is zero also. In case of sparse matrix, the non-zero values are very less. Zeros are more. In order to store, if we use the usual method, this leads to wastage of memory. The sparse matrix storage with the ordinary method, which leads to wastage of memory because it requires space for zero also, which is not necessary. For that reason, we'll be adopting a type of representation called triplet representation. Triplet means some three information. What are those three information? The one information is where is the data, like the column information and the row information, and what is the data. So in the triplet form, for this 15 we'll get 0 0 15. Why 0? Because it is in the row number 0. Why the second 0 is? Because it is in the first column 0 and the number 15. So that is written like this in the triplet form. One such entry is like this: 0 for this 15, 0 and 15. For example, this 28 is written like this. Where is it 28? In the row 5, in the column 2, and the and the value is 28. Along with the position of these items, we should know how many rows and how many columns are there. So that is the first entry in that triplet form. So the actual value is like this. For this matrix, this is the triplet entry: 6 number of rows, 6 number of columns, and there are 8 non-zero values. Those 8 non-zero values are stored from the row number 1 till 8. The first entry is 0015, second entry is 0322, third entry is 05 minus 15, next entry is 1111, 123, 23 minus 6, 4091, and 5 to 28. Some of the operations that can be performed, like we can multiply, can add them. Here we will see how to transpose. That is one such operation. When you transpose, the row data becomes columns, column becomes row, or row and column will be exchanged. Number of rows becomes number of columns. Earlier number of columns become number of rows in the transpose matrix. For this, 6 is the number of rows, 6 is the number of column, 8 values. The value will be same, but this row becomes column, earlier column becomes now row. So 0015 will be the same place, 03 will go to 30 here, 05 will go to 50, 11 will go to 11, 12 will go to 21, 23 will go to 32, 40 will go to 04. 52 will go to the row 2, 5, 28. one or two I can show you. Like, we'll take this entry. The row number is 1, column number is 2, the value will be 3. This will be placed in the row number 2 and column number 1. That means row and column are exchanged. Now to write program for this. Number of values to be scanned 8. That means we have to repeat this 8 times. The row becomes column, column becomes row. Let us take original matrix as A and the transpose matrix as B. In the triplet form, the first row is the size of the triplet, size of the transpose. The number of row now becomes column, number of columns become now row, and value will be same. Now I have to repeat this 8 times because there are 8 non-zero values. I have to use one for loop to repeat it 8 times, starting from the index 1 till 8. 1, 2, 3, 4, 5, 6, 7, 8 times I have to repeat. Now, for the first time, this is the column. That means that becomes the row. I have to look for the entries where the column is 0. That means these things. I have to take all the things, I have to put this here. First data is 0. Is any such data there? In the 0th column and in the 0th row, any data there? Yes, data is there. You put it 0, comma. Go to the next. I value 0 only. We are in the still column number 0. Go to the next entry 2. Any data is there. Any data is there. I equal to 0. Any data is there. No, 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 no. Here. 0th row. There is a data in that row. Still we are in the first row. And at the 4th column data is there. At 9, that data is 91. So that means I have to repeat this 8 times for the first row. This is 0th row, I have to repeat it 8 times. Again, for the 1 also I have to repeat 8. For 2 also I have to repeat 8. For 3 also I have to repeat 8. For 4, for 5, for that means I read 48 times of execution. I have got only 8 values, but I have to repeat it 8 times. So that is the cost of this repetition. This method is not worth. We'll find out any other such methods which saves the time. To see that program, anyway, as we'll be using structure triplet for the column information, row information, and the value. Okay, number of rows, number of columns, and the value. You can interchange this also. Like that, there are n number of terms in the sparse matrix. A triplet form is row, column, and the value. After transpose, the row becomes column, column becomes row, value will be same. For 0, 5, 15, it is 5, 0, minus 15. 0, 5, minus 15 becomes 5, 0, 15. So that is the transpose of that sparse matrix. You see the code. This is for the ordinary transpose. It takes a parameter original matrix and the resultant matrix. Let it be B. Here this n is the number of values, non-zero values in the matrix. Here it is 8. We are going to store because that many number of times I have to repeat for each of the columns. Column of A becomes row of B. Row of A becomes column of B. We are going to put these two in the first row itself. in the B of 0 row, we are going to put column value in the row value in the column, and the value itself. First entry is over. In the transpose matrix, first entry is over. Whether I have got any values here, if so, only repeat. That is why, otherwise of no use. So, if n is greater than 0, you repeat it. Okay. Next, I have to look for these columns. First, I have to try for 0th column. Next, I have to try for 1. Next, I have to look for 2. Next, for 3. Next, for 4, like that. So, I have to start from I equal to 0, I less than the column value. That means 0th column, first column, second column, third column, fourth column, and fifth column. I have to repeat for these columns 0 to 5. Then I have to see, I have to scan all these rows. For all the columns I have to see. If there are 6 columns, I have to repeat it 8 times. If there are 10 columns, I have to repeat that many number of rows, that many number of values. That is why j equal to 1, j less than n. I have to check 0 in all the rows, 1 in all the rows, 2 in all the rows, 3 in all the rows, 4 and 5 in all the rows. All the rows, that means n number of times I have to repeat. J equal to 1, j less than n. Okay. Right now we are here. Right now we are in this row because I equal to 0, I equal to 0 and the row index is 1. I equal to 0 and row index is 1. A of j, because as this becomes a row, actually that was in the column part. In that column part, right now we are scanning for the column 1. This value is equal to 0 because we are going to put this value here. I value 0. I value 0. So picking from that column, we are putting it here. Is any value is there in that entry? Yes, it is there. 0, 0 entry is there. This 0 is there. So that 0 will come here. While transferring, you have to change that column to row to column. That is why A of j, that row is now our column value. Earlier row value is now column value. Earlier value is our value place only. So that means we have put this one. Now we have to go to the next location. For that, you have to change the location current B++. Now we are going to put the value at 2 for the same column. Now column is I value 0. You have to look for I. Now j value is 2, not there. J value 3 and 0 not equal. J value 4, I value 0 not same. J value 5, I value 0. No. J value uh, J value 6, I value 0. No. J value 7 here and I value 0 only, but in this there is a value 0.4 will bring it to here by transposing. There is no value. That means we have completed 8 iterations. We got 2 values. Success rate is 2 out of 8. After transferring all this 0 index, this one and this one, we have to look for 1. Okay, that means I value is now changing to 1. Again you start from here. I value is 1. Again you start whether it is same or not. In this same, not same, not same, not same, 1 is same. You put it here. Again you repeat it. Next 2, 2 1, 2 5. That means for 1 also I have to repeat 8 times. For all 5 values I have to repeat 40 times. So that is the cost of this transpose. 540 because there are 8 entries and 5 columns. 8 into 5 like that. We will find any such easy algorithm which will reduce our work. Instead of repeating unnecessarily, we'll use other technique. The technique is called fast transpose technique. We'll be making use of some other data structure like arrays. Here I'll be counting or keeping track of number of entries of zeros, number of entries of zeros, number of entries of 1, that column 1, 2, 3, 4, like that. I'll be using one dimensional array. If there are 5 columns, 5 entries required. If there are 6 entries, I need 6 columns, like that. So that array is row terms. Row terms of 0. You start counting. That means I have to repeat this 8 times. Right now, I'm in the first row. I have to repeat it 8 times. Why 8? Because there are 8 entries, 8 non-zero values. Right now we are here. Okay. So this column becomes row. We call that how many entries are there for 0. There are 2. We'll start counting. 0. Is any entries in this row terms of 0 entries there? So increment it by 1. Earlier it was 0. Earlier, row terms of 0, 1, 2, 3, all are 0, initialized to 0. All these are initialized to 0. That is the first step. Initialize row terms to 0. Initialize row terms to 0. That is the step number 1. For initialization, we need 8 units of time. Okay, because, 6 units of time because there are 6 columns. Earlier it was row. 6 times I have to repeat. Sorry. We need to initialize the row terms that requires 6 units of time. Next, there is an entry here, increment it by 1. There is an entry here, increment it by 1. Next, increment it by 1. This is over. 3. So, row term of 3 or 2, add 1. 5. Row term of 5 you have to add 1. 1. Row term of 1 you have to add 1. 2. Row term of 2 you have to add 1. Earlier it was 0, now it is 1 now. For 3, add 1. 1 plus 1, now it is 2. 0. Earlier it was 1, now 1. So value total 2. 2. Now earlier 1, now 1. So value 2. If you count all the things, that gives you 8. 2 plus 2 plus 2 plus 1 plus 1. All together it is 8. There are 8 rows. That is the meaning. There are 8 rows. Having entry 0 2, having entry 3 2, having entry 5 1, having entry 1 1, having entry 2 2. Okay, as you can see, there are 2 entries for 0. There are 2 entries for 3. There are 2 entries for 2. There is only 1 entry for 1 and 5. So that is the meaning of row terms. This is the second step. That means I completed all this within 8 attempts. Total now time count 14. Next, in one attempt only, I'm going to put the data. For that, we need one starting position. Initially, we are going to say that use it here. This is your starting place. Any other index of the same number comes, then you should go to the next place. So one more array is required, that is starting position. So initialize starting position of 0 to 1. This is the first step. This is the one important step is required. Starting position of 0 is 1. That means we are going to put all the data from this index 1. This is the reversed one, row and column value. Now it is column and row value. So this is a place we are going to put the first data. Okay, that means starting index of 0. All these are 0, right? The first element, 0th index, we have to put at index 1. That's the meaning. Next, where you are going to put 1? Where you are going to put this one? That means you have to reserve places for 0. How many are there? So this row terms will tell how many places required. So starting position of 1 is starting position of 0, that is 1, plus row terms of 0, that is 2. That means the index of 1 is now 3. I will not bother for this for the time being. Next, what is the starting position of 2? Starting position of 2 is starting position of 1 plus row terms of 1. What is the starting position of 3? Starting position of 3 is 3 plus row terms of 3, that is row terms of 2, that is row terms of 1, that is 1. 3 plus 1 is 4. That means we are going to start the entry 2 from the fourth position. That is the meaning, this one. We are going to start, not started entering the data. We got the starting position of the index 2. What is the starting position of 3? Starting position of 3 is starting position of 2 plus row term of 2. Total 4 plus 2. 4 plus 2, that is 6. That is the sixth index, which is the starting place for 3. What is this one? We'll see that later. Next, starting position of 4 is starting position of 3, that is 6, plus row term of 2. Row term of 2 is 2. 6 plus 2 is 8. That is 8. Enter is not there. We'll see 8. The starting position of 5 is starting position of 4, that is the previous one, plus row term of 4. Row term of 4. Row term of 4 is, there is no entries here, so 0. Starting position of 4, that is 8. 8 plus 0 is 8. Okay. So we got now. That means I have to repeat this how many times? 6 times. 6 times. Because there are 6 columns. Now we'll scan. Starting from 1 till 8 I have to scan. Okay. Right now we are in this position, starting position. Is any entries here? 0, 0. Entries there? 0 entries there? Yes. You put it in the starting position itself. So we are starting now at 1 comma 1. Already we know that index is 1. So you reverse this and put it 0, 0 and 15. You scan the second row. This is the row of interest. 3. Start. So already I have put 0. That means I have to increment it by 1. Remember that starting position for 0 is not here afterwards 1. Here after 1 it is 2. Remember that starting position of 0 here incremented by 1. Remember that. Okay. Starting position of 3. This will go to 3. Entry 3. Increment that 3 by 1. That is in the next attempt it becomes 7. Remember that. Next entry is 5. The fifth, this will go here because we know that starting position is 2. That index should sit at this place. That is the meaning. So this is over. Next 1 comma 1. That means starting position of 1 is 3. Starting position of 1 is 3. 1, 2, 3. Here that will go here. Then this one 2, 1. The starting position of 2 is 4. In this place it will go 2, 1, 3. 2, 1, 3. This is the thing. Then 3, 2, 6. Starting position of 3 is not 6, it is 7. Here this will go. Here. Okay. I will explain again. We got now all the starting position. We got all the starting position, not at entered. So time consumption 6, 8 and 6. Now I have to repeat 8 times. Okay. My first data is 0, 0, 15. Where that should go? Starting position is 0. Okay. Make the entry. Reverse row and column. Reversed. The value you have to copy. Now starting position of 0 should be incremented by 1. That means 1. For the future it is 2. The next value is 3, 0, 22. 3. Starting position is 6. Go to 6. This is 1. This is 2, 3, 4, 5, 6. In this place, reverse the value and put it. Next 0, 5, 15. That starting position is 8. 8 is here. 6, 7, 8. In this place only you have to put the value. Reverse the value and put. Row becomes column. Column becomes row. Value. Next 1, 1, 15. Starting position is all these are now incremented. 6, 8 becomes 9. 6 becomes 7. And this 1 becomes 2. That you don't forget. Starting position of 1 is 3. 1, 2, 3. You put it. This is the thing. Next, starting position is 2. Starting position of 2 is 4. In this position you put no entries there, put it. Now this is also incremented to 1, that is 5. This is incremented to 4. Next value, starting position of 3 is 7. In the 7th place you put 3 2, that is the purpose. Now this becomes now 8. Increment it. After putting the value, increment it. 403, starting position of 0, that is 2. In the second place you put the value after reversing. Last one, starting position of 2, 5. In the fifth place you put the value. In the fifth place, 1 2 3 4 5. In the fifth place you put the value. That means I can complete this in 8 items. What is the total? For initialization, this is for row terms. This is for the row term, 8 number of times I have to repeat. This is for the starting position, there are 6 entries. This is for scanning. So total 24 times. Earlier it was 40 times, now it is 24. So much is reduced. That is why the name fast transpose. Fast because it is faster. We'll see the programs. As usual, it takes two parameters, the original matrix and the resultant transpose matrix. Number of columns in the resultant matrix is number of columns in the original matrix A of 0. Number of terms in the original matrix is A of 0 dot value. In the resultant matrix, the row becomes column, column becomes row. The columns in the original matrix A becomes the row of B. Row of A becomes column of B. That means we have we have obtained the first row of transpose. The first row is 668. Why 668? This 6 is this one column. The column now was the row. Value is same. Value is same. So we got now the first entry. This entry is over. We can put it. So 6 6 8. So that at entry B of 0. We have to find entries for 1 2 3 4 5 6 7 8. The next step is to initialize. That requires that many number of columns. There are 6, so 6 times you have to repeat. So this will reset the column terms to value 0, like how we have made all these are entries are made to 0. This one, this step. Next you have to find out any such columns are there. If column is there, then increment it. For that I have to repeat again 8 times. I have to repeat from here to here. If entries is there, then increase it. How to increase entry? So A of I value is 1. A of 1 dot column. Any such columns in that? Yes. 0. Increment row term of 0. So little complicated this expression, but that is the purpose of incrementing that row terms. So this you have to repeat 8 times again. 6 times and this one 8 times. Next, initialize starting position to 0. Initialize starting position to 0. Initialize. Then you have to scan starting from the first till the last. The starting position is obtained by adding previous index starting position and previous row terms value. This you have to add it. Again this you have to repeat 6 times. Then scanning all the columns, all the terms for I equal to 1. Why I equal to 1? Because the new data will sit in the first row. I equal to 1, I less than terms. So this is a starting place, like what we have taken the current be like that index j equal to starting position underscore position. The columns becomes the row value, column of a now row of a now column of b, and value same. After copying, don't forget to increase the starting position. Means after copying the item, the first item, the starting position has to be incremented because the next index value 0 now we has to put it here. Otherwise, will be put in the same place. So that is why this plus plus is required. That is why the name Sparce transpose. Thank you.